You know what I find funny these days? Everyone wants an AI that just does everything for them. Programmers open Cursor, type one prompt, and expect a full stack application to be built for them. Designers drop a rough sketch into Canva, and boom, a full logo kit appears. Writers write one prompt to Grammarly and expect a blog post to be written for them. You know, that actually made me think about two questions. How does an AI assistant know exactly what to do? And even if it does, how does it communicate with one another? When I mean communicate with one another, I mean how does Cursor communicate with my LLM? And how does my LLM know exactly what to suggest to which file that we have to make a change or any kind of edit? In this video, we're going to talk about the second question. So Anthropic stepped in and said, let's create a common way for AI systems, applications, resources and tools to talk to each other. And that solution is called Model Context Protocol. Before we understand how MCP works, we need to understand the participants involved. First, we have the MCP host. Think of it like the director of a movie. It's the one orchestrating everything. Next, we have the MCP client. Think of this as the assistant director. For every server that the host connects to, it spins up exactly one client. So it's one client per server. It's always a one-to-one relationship. And finally, the MCP server. Here is where the real capabilities live. The tools, the resources, and the data that the AI requires to perform its specialized task. There are two types of servers. One is a local MCP server that lives on your machine, and one is a remote MCP server that lives on the internet. Alright, now let's talk about layers. A layer is one part of the system that takes care of one specific job. And in MCP, there are two layers. There's a data layer and there's a transport layer. The data layer tells MCP what to say and how to say it. It defines the structure, message, and rules. JSON RPC, short for JSON Remote Procedure Call, is the writing format that MCP uses. It's like a template that keeps every message consistent. Imagine you're writing a letter. The content in that letter is your data layer. And JSON RPC could be thought of as the language that you write the letter in. But writing a letter isn't enough. It has to reach the other side. That's what the transport layer does. It's a delivery path. Is it sent directly? Is it sent over the internet? Or is it a continuous stream? For local MCP servers, the transport mechanism is STDIO. Two programs on the same computer talking to each other. No internet, no network. It's like handing a letter to a person that's sitting right in front of you. For remote MCP servers, there are two types of transport mechanisms. HTTP is a way in which applications speak to each other over the internet. It's like a regular postal system. You write your letter, put it in an envelope, and send it through official channels. And the system makes sure that it gets there reliably. And then there is SSE, Server Sent Events. That's a web connection where you keep getting updates without having to ask for it again and again. It's like subscribing to a live news feed. Instead of receiving one letter at a time, you keep getting a continuous stream of updates as things happen. So now we know that MCP has a server and a client. Each of them bring a set of capabilities to the table. And these capabilities are called primitives. Let's look at the server primitives. First, the server can offer tools. These are basically actions, things the server can actually do on behalf of the AI, like reading a file, calling an API, running a query, real operations. If the AI needs something done, it uses a tool. Next, the server can offer resources. These are pieces of information the AI can look at. Files, database rows, logs, API responses, anything the server can provide as context. So if the AI needs information, it pulls a resource. And then the server can offer prompts. These are reusable templates, little guides that help structure how the AI responds or behaves, like preset instructions or few short examples. They're basically the server saying, here's the format that works best for this task. Now, let's look at the client-side primitives. The first big capability is sampling. This just means the server can ask the client's AI model to generate something. So the server doesn't need its own model, it can just use the client's. The client can also help with elicitation. That's when the server needs the user's input or confirmation. For example, the server might say, hey, before I do this, can you ask the user? And the client makes that happen. Finally, The client allows the server to send back logs. These could be debug messages, progress updates, errors, anything useful for visibility. It's just a clean way for the server to keep the client informed. Now take a look at this kit that walks through how an MCP server and client connect, communicate, and exchange capabilities. Hi, I'm the client. I interface with the user. I manage AI inputs, produce outputs. I'm kind of like the host assistant. Okay. Tell me your name, version, and capabilities, please. Okay. I'm the client. My version's MCP 2025. I can pass requests, forward them, and I can handle responses. Okay, good. I provide tools, resources, structured prompts, and I stream updates. But do not misuse them. I wouldn't dream of it. So, walk me through your capabilities. What am I working with? Okay. Right now, I have a weather API. It gives you real-time updates of what the current weather is. Alright, I'm going to execute your one available tool, that's the current weather API. Tell me, what's the weather right now in San Francisco? Okay, I have received your request. I will now query my upstream data sources. Alright, it's 68 degrees Fahrenheit with clear skies. Wow, that was fast, dude. You make it look so easy. Hey, listen, my tool list just got updated. Hey, thanks, man. Update received. What's the new capability? It's a weather forecast API. It returns data of predicted weather. Awesome. Thanks for the update. That wraps up our overview of MCP and the components that is used to make it work seamlessly. I hope this gave you a foundation to explore MCP further.